Hi, my name is Marius Schenkluhn, and on behalf of my co-authors, I'm very happy to present you the topic of connecting home, human-centric setup automation in the augmented smart home. Today's smart homes are inconvenient. For almost all types of household appliances, there's already some smart option available. Users can build complex smart homes with smart lighting, climate control, sensors, actors, etc. spread across the house or flat. However, the association between the real device and the virtual entity within an app becomes increasingly more complex. Controlling individual devices requires scrolling through long lists of available entities, leading to nested paths through apps and unsatisfactory user experiences. If users did not lock themselves into an expensive ecosystem or build their own do-it-yourself solution, they have to rely on products and services from different brands. A smartphone screen could therefore look like a colorful mosaic of smart home vendor apps with different user experiences and setup processes. So the devices are spatially spread across the home, while they are managed within different apps on a smartphone. Effectively, we try to fit the complex user experience of a 3D environment onto a 2D screen. Many papers have therefore already suggested to solve the spatial problem with a spatial solution. There's a lot of potential for automations and complexity reduction by creating a spatial understanding of Internet of Things devices with respect to their position and their spatial relation to each other. Based on this spatial understanding, users can control smart home devices at their physical location, create automations based on the user position, and even understand and predict user intent. As an interface for this approach, many authors have already suggested future augmented reality devices for the smart home. In current smart homes, there's no need for the knowledge about the 3D position of each device. So how can we create this spatial understanding of smart home devices in a smart home? The first option could be the integration of ultra-wideband transceivers into each smart home device. While this would allow for precise positioning, as demonstrated by the Apple AirTags, that is quite expensive to have in every sensor and every device. Another option would be the use of fiducial markers such as QR codes that would be placed on each device and can be captured by using the augmented reality device camera. In this case, users would have to assign the ID of the marker to the device and attach it to the device as well, which implies a lot of manual effort. A third option would be to manually mark each device within augmented reality by placing a virtual marker on the physical device. During the setup process, the smart home could instruct each device to emit a signal, for example, a light to blink, and the user could then mark the device accordingly. Depending on the number of devices, this could also mean a time-consuming task. Therefore, we created a process to automatically capture the device position based on the sensors available in current augmented reality devices and independent of the manufacturers of the smart home devices. For this process, we rely on the affordances of each device category to attract attention. For example, smart lights, independent from their manufacturer, can always be turned on and turned off. In the case of smart lights, we can use the built-in cameras of the augmented reality devices to capture a blink pattern of the smart light and combine that with the 3D mapping ability of the augmented reality device to capture the spatial position of the lamp. Developed even further, we could parallelize this approach to capture several lights at the same time and also include other modes such as smart speakers and using the built-in microphones instead of the cameras. In terms of user experience, this approach should optimize task load, user experience constructs, and also technology acceptance. However, the smart home community has a large do-it-yourself user base. And there's an effect called the IKEA effect that captures a higher sense of connection to the system through engagement, and also a higher valuation of the product if the user was involved in the creation. The self-determination theory captures this aspect by mapping motivation to the constructs of autonomy, competence, and relatedness. Prior studies have already raised the importance of these psychological needs in the context of user experience in the HCI domain. When considering the degree of automation in a process, especially autonomy is very interesting in this study, which describes the sense of volition and being the origin of one's own behavior. Our research questions therefore relate to the manual, semi-automated, and automated treatments we demonstrated earlier, and combined with the psychological needs of the one side and the classical user experience on the other side. Our assumption is that the manual condition could maximize the psychological needs, especially autonomy, because the user is in full control of the setup process. We expect the automated setup process to perform better in terms of the classical user experience dimensions, as stated earlier, and we expect a combination, the semi-automated treatment, to strike an effective balance between the psychological needs on the one side and the classical user experience dimensions on the other side. To answer these questions, we decided to conduct a controlled lab study. In this within-subject design, each participant performs the manual treatment, the semi-automated treatment with a successive order, and the automated treatment with different modes and different devices attracting attention at the same time. The treatments with varying degrees of automation are presented in randomized order. We have a pre-treatment questionnaire that captures prior experience, a per-treatment questionnaire that captures task load, user experience, the technology-based experience of need satisfaction that is related to the self-determination theory items, and selected items from the technology acceptance model. In the post-treatment questionnaire, we ask for differences between the different treatments. We conclude the interview with a short qualitative interview. As our primary interest lies in the interaction with the system, we use the Wizard of Oz technique. We recruited our participants from the general adult population within 15 kilometers of our German lab. We had 28 participants, aged on average 36 years, with diverse residential types and diverse prior smart home and augmented reality knowledge. In general, our participants had a more positive attitude towards technology, but still exhibited some variance. Coming to the results, the user experience was rated very high over all three treatments. Still, the semi-automated and automated treatments performed significantly better than the manual treatment. We observed the same pattern for the task load, where the semi-automated and automated treatment performed significantly better than the manual treatment. When we asked for the most efficient treatment in our interviews, most participants answered that it is the automated one. However, when we asked for their preference between the different alternatives, 3 out of 4 answered that they would prefer the semi-automated version over the other two. This is an interesting finding because we couldn't find a difference between those two in the classical user experience construct so far. While their answers regarding the most efficient and most preferred version are very clear. When we then look at the constructs related to self-determination theory, especially the autonomy, we find a significant difference between the semi-automated and the automated treatment, where the semi-automated treatment performs better in terms of autonomy. The competence measure is similar to what we see in the user experience questionnaires, and the relatedness item exhibits a high variance, but no significant differences. Recurring themes of the interviews were the wow factor that underlines the high user experience, a curiosity evoking for the combination of augmented reality and smart home, and the application overall being fun. Also, it was very important to the participants in the interviews of being in control over the whole process. Common issues were learning the hand interaction in the manual treatment, the strenuous manual task, and also in the automated condition, an overwhelming and alienating sensation. Overall, we find that smart home developers must pay attention to the automation degree during spatial setup. While too much manual effort decreases the user experience, too much automation can become alienating and at the same time reduce the perceived autonomy and therefore the preference for the system. Limitations are the HoloLens 2 hand tracking field of view and quality. The fully automated approach still requires the user to walk around. Our approach requires devices to be able to attract attention, such as lights and speakers. And we use the Wizard of Oz technique, which excludes the probability of technical problems during the experiment, but also reduces external validity. Future work could look at the long-term usage in the field, the reconfiguration process if devices have been moved, the implementation of the fully automated process, and exploring additional use cases of the setup approach and augmented reality in the smart home. And with that, thank you very much for your attention. If you have any questions or remarks, feel free to contact us anytime.